Good. So now it's recording. This is March 26th, 9:42 a.m. Pacific Daylight Saving Time. And we're going to continue. So we go 26. Here's the schedule, right? 26th of March. Next Monday is a holiday, huh? So let's make sure it's a holiday. Sometimes I get those dates incorrectly, and we can go, where do we check those things, right? We check that in the catalog there. LAHC, admissions, academic department, schedule and catalog. We are in the spring semester 2025, right? So right in here, and let's see here. The holidays are at the very beginning of this catalog. Cesar Chavez Day, Monday 31st. Right? Let's see if it's Monday 31st. Yeah, Monday 31st. So next Monday we do not meet. Okay, so let's that's not what we want. We want the other one. No, nope, not this one. This one here we want. Let's move on to the next page. March 26, 25, Wednesday. I want this one here in the other one as well. Okay, and week number 6, right? No, week number 7. Okay, week number 7. Number 7. And next Monday is a holiday. What else? What else is special about this time of the year, right? In addition to this holiday, what else, right? Unfortunately, they didn't, see what happened. Spring break is they usually schedule this Cesar Chavez days and spring break all together, right? But for some reason, they put that we're going to have a class here between Cesar Chavez Day and spring break. So don't miss, okay? We're going to meet on Wednesday, unfortunately. Ideally, right? It should be the spring break, should have been here on Wednesday and Monday, and then we would meet on April 9, but that's not how that was not how they did, right? Unfortunately. So let's write it down. Next Monday is a holiday. Next Monday, March 31st. March 31st is a holiday, Cesar Chavez Day. Cesar Chavez Day. The following Wednesday. The following Wednesday, which is April 2nd. April 2nd, we will meet for the lab. Then we're going to have a spring break. April 7 and April 9 is spring break. Okay. So that's how we are. That's what's going to happen the next few days. And what else do I have to tell you? Okay, so I corrected lab number 1. Okay, check the lab correction in in Canvas. And I want to brief you how this correction. Many of you didn't take the course with me last time, right? So I didn't write down the grades yet, but I correct lab number 1. Okay, you already have your grade, and you already have your grade. Check the lab correction. Wait a minute. Download the lab correction from Canvas. This is a PDF. It is a PDF file. Okay. What else did I do? Okay, we got. Remember that we got several meetings right before you submit lab number 1. Okay, we have the meeting on the 12th of February, 19th of February, 26th of February, March 5th, 1, 2, 3, 4. And then finally, we have this other meeting here. And finally, you turn in the lab 1 on the 19th, okay? So you got a grade for all those dates here. For all those dates. What I did, you got a grade for all those dates, okay? If you showed up, you got 100%. If you didn't show up, you got 0%. And then for this grade here, which I didn't write down yet, for this grade, I'm gonna give the grade of the lab report, okay? For the 12th of March. That's the thing I like to do, to encourage you to show up, right, for the classes, especially when we are at the beginning of the semester. When we are at the beginning of the semester, you have to get familiar with the lab, how it's done. And the lab 2, let me see. Oh, wait a minute. Sorry, I made a mistake here. Lab 2 was on March 12, right? Lab 2 was on March 12. So 1, 2, let's see here. How is that? 1, 2, 3. Yeah, it looks like I made a mistake here. Lab 2 is at the 12. So it should be, I'll have to correct your grade there. Should be 3 meetings that you get either 100% or 0%, okay, for attending or not attending. And here you get the grade for lab 1. March 12 was lab 2. Let's make sure March 12 was lab 2. Yeah, March 12 was lab number 2. Okay, and I have to fix those, this grade here I have to fix. And I don't think let's see, lab 2, and the lab 2 is due today, right? Lab 2 is due today. Okay. Let me stop sharing momentarily. I want to double check here. One, 2, 3. Yeah, okay. And then lab 2. So I'll have to fix the grade for some of the grades are posted, right? Of March 5th. Yeah, I have to fix the grade of March 5th, okay? Now, so lab 2 is due today at 11:59 p.m. So let's write it down. Go back, share the screen. I correct lab 1. Okay. Download the lab correction from Canvas. It is a PDF file. At the top of this file, you have the grade for your lab. The grade for your lab. Okay. And I'm going to walk you through how you have to read that correction. What else? Let's see. I gave you grades for the following dates. 12 lab grades, right? I gave you lab grades for the following date. 25 February 12th, February 19th, and February 26th, okay? The March 5th grade in Canvas, the March 5th grade in Canvas is incorrect. So I will fix it. This grade will be the grade in your corrected lab report, the PDF document. Okay? March 12. Okay, so that's all you have. I have to tell you. Okay, download the lab correction from Canvas. It is a PDF file. At the top of this file, you have the grade for your lab. Okay, and what I want to do, I want to walk you through the PDF file that I uploaded to Canvas, which you will be able to visualize, okay? If you do not have this PDF file, let me know, and then we'll figure out what happened, okay? So let's go there to I want to show you a sample of a PDF file that I got from a student last semester. Last time that I taught this course. So you can have an idea how you can read this correction, okay? 24, fall, spring, and download itself out. Let's see if it's this one here. Nope, that's not this one here. Lab reports, lab correction. That was last time that I taught this course. Spreadsheet, maybe this one here. Corrected folder. Okay. There is one difference between what we are going to see here and what you're. Oh, maybe I should show you the other, not this one. Let me show you the other one. If necessary, we come back to this one so you have an idea how you can read that PDF file. Okay. This correction. Okay, this is a lab correction for physics 6 last semester. Okay. The format is kind of similar. It's just a different type of experiment that was performed at that time. And I'm doing that for so you can understand how this correction is done, okay? I'm not gonna show the names of the students. Let's see if yeah, here you go. I'm not gonna show the name of the student, but it is a PDF file. Okay, you're going to see your grade there at the top. Right in here is the grade of that you should be able to read, okay? On the extreme left, there is that region to put your names. And here are the tables, okay? And I have a color code to indicate where you missed, where you went wrong, okay? In this table here specifically, has no problems because there is no color code here whatsoever. Okay, you can see that they put all the units. Okay, and the numbers have the correct number of significant figures. Consequently, there is no color here code highlighting it. Now, look at the CL, right? The CL, they missed the CL and they put an incorrect value for the CL. Okay, for this reason, it's marked with this color, with this red color. Okay, and the other table is okay. They didn't make any mistakes here. Okay, and here is the table that summarizes the mistakes. Okay, they didn't miss any units. They came up with all the correct units. For this reason, there is a 0 here. 0 is in this table here is a good thing. Okay, don't misinterpret that. They missed some. No, they didn't miss any significant figures. Okay, they didn't miss any significant figures. That's why we have a 0 here. If they had missed 1 or 2 or 3 or 5 significant figures, the 5 would have been multiplied by 0.8. It would have like -4 here. They didn't miss any. They didn't add any unnecessary significant digits. Okay, and you can see R square regression equation. Okay, they missed the regression equation. So I took out 6 points from them. The CL, they missed the CL. Another 3 points that I took out. When they plotted the graph, there was some missing labels in the graph and I subtract 6 points. That's how you should be reading this table, okay? So, are you following? Let's take a look at another one here. You know what? I think it's better that I show you the corrected one for P07. Okay, now that you know that, here you go. Here is the same. What's going on here? Yeah, Google Chrome. Yeah, here you go. Okay, that's more like what you're going to see in your PDF file. You might need to zoom in and zoom out, okay? So take a look here. See, they put all the units, right? You don't have to worry about this one here, this line here. One day I'm going to delete this line here. But look what happened here. They added unnecessary significant figures to this column. That's why it's highlighted in green, light green. Here is the contrary. They missed the significant figures. That's why it's highlighted in blue. And the color code is right here, okay? Significant figures that are missing, significant figures that are added. If they missed any units, should be in red color, okay? And then what do we do? You know, I wrote a computer program that corrects this lab report of yours, okay? That's why I don't want you to move anything around in that table. Okay, don't move any of the cells, don't move any of the tables. Leave it in that format because my computer program relies on the proper position of the data that you have there. Here you go, regression equation. They put a number here, you know, and they're supposed to put an equation, but the number of data points is 5. 1, 2, 3, 4, 5. Yeah, it's right. That's why it's not highlighted. The CL is correct. That's why it's not highlighted, okay? Do you get the idea? It's a color code type of thing. And look at the units. And here in the last table, you have to put the numeric value of the slope. That's what you're supposed to do, okay? The slope here, the electric field coincides with the slope of the graph. And don't forget to put the units. Okay? And here's the table where I'm taking out the points from you. If you don't put the proper labels on the graph, I'm going to take out points. Here I took out 1 point from this group last semester because they didn't put the labels, okay? This time I didn't do the equipotentials. So wait a minute. This time, okay. If you didn't plot the graph, right? If you didn't show the graph, you lose 15 points. Okay. In this case here is a case in which they did plot the graph, but they didn't optimize the graph. That's why they lost so many points. Graph 2, if you don't show the graph 2, you lose all the 15 points. In this case, they are okay. They didn't have any problems with graph number 2. Regression equation. They didn't put the regression equation. So I'm taking out 2 points from this group. Okay. If field lines, I didn't ask from you today. I didn't ask you this time. Okay. Slope. They logged the value of the slope. Consequently, I didn't take out any points from them. They got the right CL. That's why I didn't take out any points from them. And the R square, yeah, they got the right R square as well. Okay. Only the significant figures that were added, they had 6 significant figures that were added, incorrectly added to the numbers. And I subtract 1.8 points, 0.3 for each added significant figures. They didn't miss any significant figures. They only added significant figures, okay? That's how all my lab corrections are going to be. They're going to point out everything that you missed, okay? And if you have any questions about that, right? Let me know. I'm going to write down. I want you to visualize. Let's I'm gonna put this guy right in here. Okay. For this lab, for lab number 1, not for this lab, for lab number 1, any mistakes are pointed out with a color code, okay? One, if you missed any significant figures, no, if you didn't get did not get the right unit. The mistake has a red color code. Okay. 2, if you missed a significant figure. Okay. Okay. Thank you for letting me know. Thank you for letting me know, Mary. I'll check that. Stay after the office hour. Stay out today for office hours, right? And we'll figure out that. Okay, Mary. Okay. If you miss a significant figure, the color code is light blue. Light blue. Right. 3. If you added unnecessary significant figures, the color code is green. If you missed the R square, the CL, and the slope, the color code is brown. Okay. Everything else doesn't have a color code. Everything else, such as optimization of graph, optimization and label of the graph, of the graphs, comma, does not have a color code. Okay. And HEMA, that's okay. HEMA, stay after hours too, and then we see what's happening. Okay. That's what we have. The table at the bottom. Everything else, such as optimization and label of the graph, does not have a color code. Okay. The table at the bottom shows where the points were subtracted. Okay. Where the points were subtracted from. And at the very bottom of the table, you have the grade for your lab reports. Okay. So that's what I want to share with you. Okay. And let me write it down too. If you are missing your PDF file with the correction of lab 1, lab number 1, stay during the office hours. Figure out, right? What's happening, okay? Also, if you believe you're not giving the proper grade, just stay for the office hours today, okay? That's what I want to share with you. Any questions? Any more questions? You're supposed to look for the PDF file in the Canvas. Okay. Some of you didn't get the PDF file because in the same place where you uploaded your spreadsheet, do you remember? In the same place where you get your uploaded spreadsheet. That's where you should look for this PDF file. If you do not have this PDF file, most likely that's because I got a spreadsheet that didn't have anything in there. Okay. Let's see the view. The grade gets submitted already. I have grades only. I have only 4 grades there. Okay, Ramon. I have only 4. I didn't log the grades for the lab 1 yet. Okay, like I mentioned before, the first 3 meetings, if you showed up to the lab, you got 100. If you didn't show up to the lab, you got 0. Okay. The 4th meeting is the actual grade of lab 1, which I didn't submit yet. Okay. So let's see. 10:15. Again, if you have any questions, I want to know if you folks were able to download, if anyone was able to download the PDF, right? Abir, were you able to download the PDF?
Yes, I was.
Huh?
Yes.
Yes, okay, good. So the system is working, right? Amber, were you able to download the PDF file with the correction? See. Doesn't look like Amber is in front of the computer. What about Nestor? Nestor, were you able to see your PDF file?
I'm trying to check it right now. I'm going through the Canvas right now.
Oh, you're going to go to Canvas right now. Okay, good. Let me know if you can see that. Like I said, just not everybody that I was able to correct, because whatever spreadsheet that I got from Canvas, there was a few students in there that didn't do the spreadsheet, didn't work on the spreadsheet. Okay. Let's see, lab correction. Another student coming in. Benjamin, were you able to download your PDF file? Yes, okay, good. Elizabeth Castellano, were you able to download your PDF file? Elizabeth Castellano here, yes, she's here. Okay, looks like Elizabeth's not around. Jacqueline, were you able? Jacqueline Delgadillo, let's see, it doesn't look like she's here, no? Okay. Juan Escalera, were you able to download your spreadsheet? Were you able to download the correction to your lab 1 in PDF? Yeah, it looks like Juan Escalera is not here. Bianca? Hello, Bianca.
I'm here.
Okay, were you able to download your PDF?
Yes, I was.
Okay, good. Okay, so it looks like the system is working. Okay, I'm not going to ask more the rest of the students. So if you cannot see your PDF, just stay around for the office hours and we'll figure out what's going on. Okay. Going back to, so what I want to do, I want to cover some material. the lecture, okay? And then we can do lab number 3, okay? Let's see, lecture. You were not given, right? We're not given a proper grade. Just stay for the office hours. And let's see where we stopped last time. Okay, we stopped at magnetic force in the current. Okay, study this, this drawing very carefully, okay? So you can understand how we can implement in practice, right? In a useful device, like how we can use the force in an electric current in a useful device. Many of the stuff that we have out there is just physical principles. Just like the engine of your car is a physical principle that was studied and then implemented into practice. The speaker is the same thing. The speaker works in a way according to the laws of physics. Okay, and the speaker moves back and forth exactly because all those wires of the current are being subjected to this force, to this back and forth force. Okay. And what I want to do now, I want to talk about torque. Torque in a current carrying loop. Okay. And that's exactly what 21.6 is all about. Torque in a current carrying loop. And by the way, again, this type of thing has practical applications. It's not just one crazy theory that has no practical applications whatsoever. Yeah, it does have. And this specific topic has applications in electrical motors. Your blender, for instance, is one application of this topic. How your blender works is one type of application of this topic. Any electrical motor uses this idea here. What happens to a loop that carries a current? What happens to this loop whenever it's subjected to a magnetic field? Okay, so the question you have to ask is the following. What happens to a current carrying loop whenever it is subjected to a magnetic field? But it's not just any type of current carrying loop, okay? What happens to a current carrying loop that varies in time and direction, okay? Whenever it's subjected to a magnetic field. That's what you have to ask yourself. And we're going to look at a drawing here so you can understand. The book also have something like that, okay? Let's take a look here in the book. And there are all sorts of simulations in the internet that you can consult. and learn again. You know, the best way to learn physics, if you don't have the actual device, if you're not doing the actual experiment, the best way to learn physics is to check those simulations that we have out there in the internet. You know, unfortunately, we didn't have those things during my time as a student. During my time as a undergraduate student, we didn't even have internet. Okay, nowadays the internet is so powerful, has so many simulations out there, is amazing, you know. So here you go, while course, and I will show you one of those simulations. But before I show you one of the simulations, let's take a look here at the book. 21, here you go. Torque in a current carrying coil or current carrying loop. We see here, that's what I mean by a loop, okay? So we can have one, in this case, you have only one loop, but you can have 2, 3, 4, 5, 6, 7, 8, 9, 10 loops. The larger the number of loops, the easier it's going to make this loop rotate, okay? And let's see. If a loop of wire is suspended properly in a magnetic field, the magnetic force produces a torque that tends to rotate the loop. This torque is responsible for the operation of widely used type of electric motor. Okay, so let me show you my drawings. My drawings are going to be much simpler than what you see there. Let's skip this one. Okay, here's my loop. Okay, here you go. Here's the loop again. And my loop is subjected to a magnetic field. Okay, here you go. The loop is not in the plane of the screen, so it's tilted. And it's carrying a current. I'm gonna call it, the current is the same, okay? But I'm going to call it I1, I2, I3, I4, just to, you know, I'm gonna do it better than that. Let's see, instead of I1, I3, I4, I'm gonna put like that. Here you go. Here is arm number 1, okay? The current is going to be the same, so I don't need to put different currents here. Here you go. Here too is going to be I2, right? What I mean by the 2 number there, the 2 number there I meant is the arm number 2, okay? Arm, here's gonna be arm number 3. It's not I3, okay? I3 gives you the impression that's a different current, but it's not. The current is the same on all those 4 arms. 3. And we have 4. Okay, I'm gonna take out this subscript. Okay, 1, 2, 3, 4. I'm gonna need that. Keep track where the force is, okay? Yeah, again, I'm going to remove all those subscripts. See, I'm just, you know what? Let me erase that because I'm playing the movie here, right? We don't need to put that. So here you go. Let's play the movie again. We have this loop that is going to be subjected to a magnetic field. The magnetic field is pointing into the screen, into my screen. And this loop is not in the plane of the screen, okay? We do not need this slide. Okay, and this loop, we're passing a current through this loop. And we are going to distinguish each of those 4 arms, arm 1, 2, 3, and 4. They are color coded to help you understand what's going on, okay? And again, here we go. The length, the horizontal length of the arm is equal to A. And the vertical length of the arm is going to be equal to B. Oh, B sine of theta. Okay? B sine of theta, where theta is going to be the angle that the loop makes with this screen, with the plane of this screen, okay? So it's going to be something like that. Here you go. You know, the loop is somewhat like that, let's say. Yeah, is tilted like that. This arm here, B sine of theta, is the arm that's tilted with respect to the plane. Okay? That's why it's a little bit shorter. It's a little bit shorter because of its projection in the plane of the screen. Let me remove that as well. Okay, so here you go. That's what I mean by an inclination, right? If here is the ZY axis, okay? Now here is going to be the XY axis. Do you see the direction of the magnetic field? Okay? You see the direction of the magnetic field? And the B sine of theta is going to be this length here that we are seeing. Here is the theta angle. Let's go back again. We're going, you know, that figure that you see is just the figure being looked at another angle. Okay? I rotated this figure, let's see. I rotated around the y-axis. That's what I did. The axis of rotation of this figure in the next slide is a rotation around the y-axis. And now the axis is pointing towards you. Okay, and now we can start looking, here you go, here's the angle theta. Okay, and then we have to start looking at the forces, okay? Since we have a current carrying wire here, we go, I1 is into the board, I3 is out of the board, just like that, right? I1, I2, I3, I4, right? Like that. So when we come up with the magnetic force on those 2 loops, we get this force here, 1 and 2. Don't forget it's I cross B, right? I cross B, you know, just do the right hand rule. I in this arm here, in this lower arm is, here you go. In the lower arm is into the board, the B is to my right. Okay, so you gotta do the right hand rule. I, the palm pointing along the I, cross B. Okay, so you have this force downwards in this arm of the loop. You do the same for this top one, and we get an upward force. I cross B. The forces are canceling each other, but not the torque. This loop behaves like a rigid body. Okay? Let's take a look at the other. Okay, so it tends to rotate in this direction. Okay, tends to rotate in this direction. And now what about the current? I2 and I4, right? I2 is the arm on the bottom, and I4 is the arm, and 4 is the arm on the top. And I'm going to put here arm number 2. Arm number 4. And I'm going to draw, I'm going to make this other one here, this color. I'll make a little bit thicker, right? Okay, like that. And now you go ahead, do I cross B, right? I cross B on the top arm is going to be this force that you see right in here. Arm number 4. And I cross B on the other arm is going to be this other force here, F2. You can see that those two forces, not only they cancel, but their torque also cancel. Contrary, unlike the other case, right? Unlike the arm 1 and 3. Arm 1 and 3, the torque do not cancel. Makes the loop rotate in the counterclockwise direction. Do you follow how this thing happens? Okay. The torque of those two forces is 0, and so is the net force of those two forces. So we have only the torque due to arm number 3 and arm number 1. And again, I will erase this I1, and I'm just gonna label arm number 4. Arm number 4. Oh, 4. And now, depending how the current is flowing, okay, this loop is going to rotate in a certain way. If the current is constant, okay, the loop is just going to oscillate back and forth, okay? Well, let's see if I have it here in my, yeah, here you go. Yeah, here you go. See, the loop is rotating, right? It has some inertia. At this very point here, when the loop rotated from, oh, let's see. Yeah, from this position to this position, the loop still have a angular velocity, but the net torque is going to be 0 at this position. You see what's happening here, right? And I'm going to make this guy thicker. Gonna be a little bit thicker than that. Yeah. Okay. Although then there is one more thing. Although, and I'm going to repeat that. Okay, maybe you're not following everything, but I'm going to repeat that. Not just I'm going to repeat, but I'm going to write that down so you can follow more carefully there at home. Okay, because this loop now has some angular velocity, okay, it is going to overshoot this position. Can you picture that? It's going to overshoot this position. But by overshooting the position, something else is going to happen. The torque is going to change the direction. Okay? The torque after overshooting that position of equilibrium, here is the position of equilibrium, right? After overshooting this position of equilibrium, the torque is going to change the direction. Now the torque is gonna be on the other direction. Here you go. Out of the board. See here? Let's see if we had the torque here. Yeah, here the torque is into the board. Okay, making the loop rotate in the clockwise direction. But after overshooting it, the torque is gonna decrease the angular velocity of the loop, and eventually the loop is gonna rotate in the other direction. Okay. Let's see if I have it. Yeah, okay, so I don't have more than that. And it's gonna oscillate back and forth. Okay? It's going to oscillate back and forth. Something like that happens only if the loop starts, only if the time t equal to 0, design of the loop makes an angle with the plane. So let's start all over again. Go right in here. And here's the lower arm of the loop, right? The green arm is the lower arm of the loop. This other arm here is the upper arm of the loop. I'm going to okay, torque in a current carrying loop. Loop has 4 arms. Arm 1, 2, 3, and 4. Arm 1 and 3 have a length A. Arm 2 and 4 has a length B. Okay. Arm 1 and 3 are perpendicular to the B field. Let's take a look here. Arm 1 and 3, see that? 1 and 3 are perpendicular to the B field. At time, or even better, at time t equal to 0, right? At time t equal to 0, arms 1 and 3 are perpendicular to the B field. Okay. Magnetic force applied to each arm 1 and 3 is IAB. Okay. Magnetic force applied to those 2 arms. Net force, right? Each of those forces are opposite in direction. Net force is equal to 0. But because of the configuration of this loop, okay, the net torque on arms 1 and 3 is going to be 0 as well. Torque of arm 1 and 3 in the same direction. Let's see, 1 and 3, let's see here. Now, wait a minute. Arm 1 and 3 has a net torque, right? I misspoke here. Has a net torque. And the net torque has a net torque because there is this angle that the loop is making with the plane. Torque of arm 1 and 3 are in the same direction and reinforces each other. 2IA B sine of theta. The net force is 0, but not the net torque. On arms 2 and 4, the situation is different. Arms 2 and 4 make an angle theta with the B field. We go arms 2 and 4 makes an angle theta with the B field. Here you go. And what else? Magnetic force applied to arms number 2 and 4 is IBB sine of theta. If each of those two forces are opposite to each other, and just like before, the net force is equal to 0. But unlike the other situation, the net torque is going to be 0. See the difference? Okay. Net force on those, here you go. Arms 2 and 4 into the board, up the board. Okay. Because of this specific orientation of this loop, the net torque on those two arms is going to be equal to 0. And what follows? What follows? Okay. Is the following. I can come up with 6, right? Yeah. What follows is the following. What follows is the following. A. Loop will rotate. Loop will rotate in a clockwise direction. Okay. Clockwise direction due to the torque. Since the torque is dependent on the angle theta, okay? Look right in here. The torque right in here, depending on the angle theta. It's it will progressively decrease, The torque will progressively decrease. Decrease, okay? Until it makes an angle of 90 degrees with the B field. Until when the arm of the loop makes an angle of 90 degrees with the B field, an angle of 90 degrees with the B field, the net torque becomes 0. But at this point, the loop also has an angular velocity, which will make it overshoot this position of equilibrium, okay? When the arm of the loop make an with the B field, the net torque and becomes zero. Both torque and net force, both the net torque and the net force are zero. This is the position of equilibrium. Okay. But at this point, the angular velocity which will make has an angular velocity. At this point, the loop also has an angular velocity, making the loop overshoot its position of equilibrium. Like that. Here you go. Net torque is equal to zero. Should be net. Okay. Once it overshoots, the torque changes direction. Once the loop overshoots its position of equilibrium, the torque changes its direction and starts to slow down the loop. Okay. Now the loop is in to counter the counterclockwise direction. The counterclockwise direction and start to slow down the loop. Until the loop, I'm gonna put one more slide here illustrating, let's see, illustrate, can I get that? Size and position. Let's see, position. Yeah, it doesn't look like I'll be able. Let's see here. Bring to front. Huh, strange. How did I do this? Yeah, it doesn't look like I can change it. What I want to do, I want to change, make it rotate further than that, but for some reason I cannot do that. Okay. Once the loop overshoots its position of equilibrium, the torque changes its direction to the counterclockwise direction and starts to slow down the loop. The loop reaches its maximum angle and starts moving in the direction of the loop, of the torque, okay? Of the torque. After that, the torque, the loop just keeps on oscillating back and forth. Okay? It's gonna be oscillating back and forth. And that if they keep oscillating back and forth, if the current does not change direction. If the current keeps on going in the same direction, keeps on going in the same direction. the same direction, okay? Counterclockwise direction. Did you get the idea? Okay, so notice that the loop oscillates back and forth, because it started with an initial angle with respect to the, because it started initial with respect to the B field. However, very important, if at t equal to 0, the angular velocity of the loop is 0, and the plane of the loop is perpendicular to the B field, comma, then there will be no oscillation, okay? So the situation is like the following. I'm gonna get right in here. I want this one. Now, suppose that at time t equal to 0, t equal to 0, omega is equal to 0, okay? If omega is equal to 0, then there will be no torque whatsoever applied to the system, okay? Net torque is equal to 0, and there will be no oscillation, okay? So notice that it also, however, if at t equal to 0, the angular velocity of the loop, and that should be a continuation of that, okay? Is 0, and the plane of the loop is perpendicular, then there will be no oscillation, because there will be no initial net torque, and the loop will not oscillate. Will not oscillate. Okay? There will be this situation here. Loop does not oscillate. Does not oscillate. However, if the time t equal to 0 is something like that, see this one? Yeah, this one right here. Okay. However, if the time t equal to 0, you have this type of configuration, then the loop does oscillate. Okay? It all depends on the initial conditions. Loop oriented like that, angular velocity equal to 0, time t equal to 0, initial angular velocity is equal to 0, net torque is equal to 0, loop does not oscillate. However, if at time t equal to 0, the angular velocity is equal to 0, but there is an angle that the loop makes with the magnetic field, then the loop does oscillate. Okay? And one more thing, you know, and I'm going to use this one right here. If current keep on flowing in the same direction, if current flows in the same direction, comma, loop oscillates back and forth. That you already know, right? And I'm going to put a double arrow here for this guy here. Okay, double arrow. Oscillation back and forth. Okay. However, however, here you go. If current changes direction at the point of equilibrium, comma, and then I have to change the direction here. At the point of equilibrium, then the loop keeps on rotating. Very important. That's how electric motors work. Okay, that's exactly how electric motors work. So here you go. I'm gonna change the direction of this torque, and no, I'm gonna change I have to change this one right in here. Keep on rotating. Okay. See the difference? 3 situations, right? 3 situations. Okay, so we have 3 situations. So we have 3 situations. I'm going to start with the simplest one. One, if at t equal to 0, the angular velocity of the loop is 0, and the plane of the loop is perpendicular to the B field, and the loop will not move. Okay? We do have a force there, but there will be no torque whatsoever. Okay? If at t equal to 0, the angular velocity of the loop is 0, and the plane of the loop makes an angle with the B field, the loop will oscillate back and forth. Okay? And then you have this other third situation. If the one more, and the current keeps on flowing in the same direction, okay? The loop will oscillate back and forth. And then we have the third situation that's applicable to electrical motors. If at t equal to 0, The angular velocity of the loop is 0. The plane of the loop makes an angle with the B field, but the current changes direction at the position of equilibrium, comma, then the loop will keep on rotating in the same direction. Okay? Those are the three situations that you have to remember. It's not difficult. Just make this analysis that I did. And now we are ready to see the simulation of a loop inside a uniform magnetic field, okay? I'm going to simulation of a loop, of a current loop inside a uniform magnetic field. Here you go. We're gonna go in a break very soon. Okay, here you go. That's the simulation that I have. I have the link for the simulation. Okay, look at my loop, okay? We have just one loop here. Let's see how I'm gonna pause that. We have just one loop here. This loop is subjected to a magnetic field, a uniform magnetic field. Those black arrows is what we call the force, okay? The Lorentz force. Here you go, turns on, Lorentz force. That force that is applied to electric charge and to a current carrying loop is called the Lorentz force. Lorentz force. At this moment in time, the Lorentz force has a given value. And don't forget it also, even though the forces are, the net force is 0, the net torque is not 0, okay? As the loop keep on moving, here you go. This force is going to decrease until it becomes 0. Not the force, the torque will decrease. At this very moment, the torque is 0. Just before that, okay, just before that, the torque is 0. And note, see what happens here to the direction of the current, okay? See, it changes direction. The current that you gotta see is here in the loop, not here in the battery, okay? Here we have a battery. Let me slow it down so you can see it better. Okay. Let's increase a little bit more, otherwise this guy is gonna be very slow. Look at that, here you go. This arrow here in the loop is the direction of the current. This current here doesn't change direction. It's always pointing the same direction. What changed the direction is here in the loop. Okay, see? Because we have a device here that's called a commutator that manages to change the direction of the current of the loop. So it's going, if this arm is pointing in this direction, watch it, it's gonna change the direction in this arm, watch out, watch out. Okay? Now it's pointing away from the commutator, see that? Pointing away from the commutator. And then when the plane is 90 degrees, this arm here, the loop, the current is going to change direction again. Watch it. Yeah, see, it changed towards the commutator. Okay, it was away from the commutator. Now you go. Now it's towards the commutator. Let's wait another quarter of rotation. You're going to see that the current here is going to point away from the commutator. There's a little bit lag here because of the simulation. See? Wait. Here you go. Pause. See here? The current. So those are the things that we have out there in the internet. The link for this for this simulation is going to be in my notes. Okay, and now we can start talking about we can take attendance and 19 today is this 26. March 26, 25. Abir Ahmad, are you there?
Yes, I'm here.
Okay. Next is Nestor Alvarado. Hello, Nestor. Nestor was here earlier.
Yeah, I'm here. I'm here.
Thank you. And next is Monte. Hello, Monte.
I'm here, Professor. I'm here.
Thank you. Hasti, Amin. Hasti, I don't see Hasti here. Hasti, Amin. Okay, so is Isabela Ballesteros. Hello, Isabella. Doesn't look like Isabella is here. Next is Justus Bolden. Thank you. Alexandra Burmistrova.
I'm here.
Thank you. Benjamin Carvajal. Thank you, Benjamin. Elizabeth Castellano. Thank you, Elizabeth. Natalia Cordoba.
Here.
Thank you. Next is Jacqueline Delgadillo. Thank you. Jenny Diaz.
Here.
Thank you. Valerie Diaz.
Here.
Valerie. Oh, she's here. Okay, good. Thank you. Juan Escalera. Let's see. Juan is not here. Yeah, I don't see Juan here. Next is Bianca Eloki. Bianca, are you there, Bianca? And looks like she's away from the computer. Dana Gomez. No, Dana, not Ely. Okay, so it looks like Dana is no longer with us, right? Eli Gonzalez.
Here.
Thank you. Manuel Hernandez.
Here.
Thank you, Manuel. Samantha Hubert. Let's see, Samantha here. I don't see. Yeah, I don't see Samantha in my list. Next is CJ. Are you there? Okay, thank you, CJ. Luis Leal, are you there? Okay, Luis Leal is not here. Bianca. Okay, thank you, Bianca. Next is Amber Lopez. I see Amber here in my roster. I don't hear from Amber. I'll put a little star here. Arely Lopez.
I'm here.
Thank you. Genesis Lopez.
I'm here.
Thank you. Mary Michaelian.
Here.
Thank you, Mary. Galia Odabashian. Thank you. Ramon Olivares.
Here.
Thank you. Taylor Thorne. Are you here, Taylor? I don't see it, Taylor here. Okay. Next is Jeremy Pittman.
I'm here.
Thank you, Jeremy. Stephanie Ramos.
I'm here.
Thank you. Leslie Rios.
Here.
Thank you. Jason Strait.
Here.
Thank you, Jason. And Hema Torres Navarro. Emma was here before, right?
I'm here.
Okay, thank you. And let's see how many we have. 26 students. Yeah, it's just Amber. Are you there, Amber? Amber Lopez. Okay, thank you. Now the numbers match. It is 11:12 right now. Let's have our break. And then when we get break from 11:12 a.m. to 11:27. Okay. So I'll see you in 15 minutes. I'm back here. Let's take a look again our syllabus. Right, here you go, resistance measurement. That's gonna be today's lab, okay? This lab is gonna be simpler than the other two that we had. So it's gonna be, let's see, 1, 2, 3 graphs. Let me upload this lab for you all, okay? And we have 27 students. Okay, so let's see how I'm gonna do that without. Let me stop sharing my screen first. Yeah. Okay, I didn't create lab 3 yet. Let me create a lab 3 now for you. And I can start upload. So I can start uploading the spreadsheet. Assignment, lab 03. Lab 03, okay, 100 points. Now upload, allowed attempts. Okay, let's put unlimited for now, but there is a deadline for this due date. The due date of this lab is going to be lab 3. Yeah, it's going to be 7 days from now. Next week, okay? April 2nd. April 2nd, available from today. Let's see if everything works. Save and publish. Now let's go to your 1, 2, and 3. Yeah, right here. Okay, let's start one by one.
Professor, we never finished lab 2.
What did you say?
We never finished lab 2.
Oh, we haven't finished.
No.
Okay. Let's see. Let me see what was missing lab 2. It's okay. If we don't finish, we can finish it. Let's see. And lab 2 was 12 of March, right? 12. Can't be 12 of March. Ah, yeah, it's 12 of March. Huh. Wait a minute. See here, yes. Okay, not this one. I'm looking at the wrong document here. So let's see, electric circuits. Wow. One more student coming in. Huh. Let me check my notes here. I suspect that we did finish lab 2. Let's see. P12. Do you remember where we stopped? My notes here shows that we covered almost everything, but let's see. P3F. Okay, let's. I'm gonna go through lab 2 again. Okay. Yes, we did finish. We did not finish lab 2, right, Benjamin? Okay. Okay, let's do it. Okay, so if you didn't finish, we did a big portion of it. But I don't remember if we did any work. Okay, so let's so let me just update here my syllabus. And then I can start. Oh, sharing the screen with you. Lab 2 instead of lab 3. So now I'm going to put this guy down in here, and then I'll fix the rest later on. Okay, lab 2. Continuation. Okay. So if you didn't finish lab 2, then we have to postpone the date for lab 2. We're turning in the lab 2, and let's get the spreadsheets. Lab correction, raw data. Lab 2, copy. Okay, so the lab is not available for me to download. Okay, let me check. Is it because, let me see, I think I know why. I gotta stop sharing again. let me. Assignments. Lab 2, available. Let's see, I'm going to, okay, since we're going to do lab 2 today, let's change the due date. 26th of March is going to be April 2nd, okay? So now you have, but yes, it's a good idea because this lab is kind of difficult, right? It's kind of difficult to do because it does some funny graphs. Okay. And let's see, Juan is telling me that he does not have lab 2 there. Let's see what's going on here. Juan Escalera, right? Yeah, okay. Okay, you don't have lab 2 there because you didn't come the last time, but I will upload that for you, Juan. Okay, so submit for student. It's not what I want. It's this one that I want. Let's see. Oh gosh. Uh-huh. Raw data. Lab 2. And here you go, Juan. Now you have it. Confirm with me that you have your lab 2 there. Okay, Juan? Does everybody else has the lab?
Professor, I don't have the lab neither.
Who is that?
Jenny?
Jenny? Okay. So
Yeah, neither do I.
write your name there in the chat box if you don't have your lab 2 spreadsheet, okay? Go ahead, I don't have lab 2, write down, I don't have lab 2 spreadsheet, and then write down your name, okay? Let's do this way so it makes things simpler for me. Okay. Okay, so Natalia, right? Ramon. Oh, Ramon has lab 2. Okay, Natalia doesn't have it. Galia doesn't have it. Jenny Diaz doesn't have it. And Jeremy Pittman doesn't have it. Okay, so 1, 2, 3, 4. Okay, Natalia Cordova. Okay, okay, good. So let's start with Natalia Cordova. Okay, Natalia, now you have it. Let's see, Galia, right? It's so nice to have this canvas thing here. Submit for student. Let's see here. Okay, Galia, now you have it. Next one. Next one is Jenny Diaz, right? Let's go for J. It shows that I upload that for you, Jenny. Can you please confirm that you do not have it? Wait a minute, let's see. Okay, let's see. Okay, I will upload it anyway. Here you go. Here you go, Jenny. I didn't upload lab 3 yet, okay? So we can wait. We can wait until next meeting. Next lab meeting. Let's see. Jenny don't have lab 2. Jeremy Pittman. Jeremy Pittman. Yeah, it shows that you also have it, Jeremy, lab 2. Well, but I will upload it again. Submit for student. Okay, as I have now, I don't have it either. Valerie doesn't have either. Okay, let's see. Valerie. Yeah, Valerie, that's right. My notes show that you do not have it. Submit. Okay, you should have it now, Valerie. No. Okay. Everybody should have lab 2 now. Okay. Okay, so now let's open lab number 2, right? Okay, so I'm going to repeat what I listed before for lab number 2. Here we go. Because those are all the notes I have for lab 2 on the 12th of March. Let me share my screen. Okay, so here you go. List of materials is the same list of materials that we got for the previous lab: resistivity paper, conductive pen. I'm going to go through it very quickly because it seems I went through that before. It just happened that we didn't finish, right? Cork board, right? And let me get the illustrations as well. Add slides. Yeah, resistivity paper. Oops. Is the black paper that I mentioned to you that we also used in the previous lab. Here you go. But this resistive paper, instead of having 2 parallel plates, we have a different configuration. We have a circle around a dot. Those are the 2 electrodes that we have in there. With a different configuration, right? Instead of 2 plates with a space between each other. Now we have this dot in the center, electrode dot in the center, and a circle around it. Resistive paper on the top of a cork board. Insert 4 pins to the edge of the paper to secure it on the cork board. Insert 1 pin anywhere along the outer electrode, preferably at the place where you already have a hole. Okay, and insert another pin on the middle electrode. And turn power supply, set it to 10 volts, and leave it there for the remainder of the experiment. Connect the outer electrode to the negative polarity of the power supply using the black cable and the alligator clip. Connect the inner electrode to the positive of the battery using the red cable. And now we have positive and negative charges. Positive charges in the inner electrode, negative charges in the outer electrode. Notice that this problem has circular symmetry, right? Notice that. So right from the bat, we can, kind of figure out that the equipotentials are going to be circular as well. Okay. So here we go. Connect one end. Okay. Blackjack or multimeter. So we're going to have the multimeter there. And the multimeter is going to start taking measurements. But before you start taking measurements, you have to visualize an x-axis running in the horizontal direction through the center electrode and a y-axis running in the vertical direction through the center of the inner electrode. And then we start collecting the data. The first data that we're going to collect is going to be along this x-axis here. We're going to measure the potential difference with the multimeter. Okay, and so here you go. It's going to be, here you go. Initially with half volt. Okay, initially with half volt. Then we're going to get 1 volt. That's a number that works pretty well. And then 2 volts, 3 volts, 4 volts, and 5.5 volts. Okay. Notice that I put them everyone in different colors. And that's exactly how I performed the experiment, the actual experiment with my students. Now that we collected those data points along the x-axis, we are going to collect data points along the y-axis, but just in the positive y-axis direction, okay? And here you go. We have half volt, 1 volt, 2 volts, 3 volts, 4 volts, and 5.5 volts. Okay? We have 2 points for each equipotential right now, and we need to get 4 more points for a total of 6 points. That's what I like to do when I perform my experiments. I like to collect at least 6 data points. I like to collect at least 6 data points. Okay? So what we're going to do next? Okay, we're going to collect 4 more the coordinates of 4 more points of with a electric potential of a half volt. What I tell you, might tell my students that ideally when you're performing this experiment, you do not want all those 4 points in a single region, okay? You don't want anything like that. You want them as evenly spaced as possible, okay? You want them as evenly spaced as possible. Okay, so you should have, ideally, you should have something like that. Half volt, 1 volt, and then as we move towards the center of the circle, the arcs here become smaller and smaller. For this reason, we have to start collecting data points here in the second quadrant, okay, for the 2 volt equipotential. See here, 1, 2, 3, 4. We have 1 data point in the second quadrant. For the 3 volts, 2, we have 1 data point in the second quadrant. 2 data point in the second quadrant for 4 volts and 5.5 volts. That's because the arc becomes smaller and smaller. Okay, that's why we have to invade the second quadrant. Now, what you have to do now? You have to plot. You have to plot the equipotentials. Okay. Procedure, setup, 50, 60 steps. All this procedure is spelled out here. And I just went through the procedure, actual measurements. First measurements, find the coordinates of a point along. Repeat 3A for the following 1, 2, 3, 4, and 5.5. Repeat 3A and B for y-axis, x is equal to 0. Now find coordinates for 4 more points of half volt. Repeat 3D for 1 volt. Repeat 3D for 2 and 3 volts, but get the coordinate of the 4th point in the second quadrant. Okay, and here you go. And we do that for 4 and 5.5. Okay, and those are the data points that you have in the table. Okay, here you go. Look at the table here, right? Here's the value of the voltage that we are measuring. That should be close to half volt. It's not exactly half volt, it's 0.504, 0.502, okay? And then you measure the x and y coordinates of these points. Okay, and another, let's see if I got my ruler here. I didn't put ruler here, right? Yeah, I gotta put ruler for measuring the coordinates of the data point. And what's the resolution of the ruler? The resolution of the ruler, resolution is equal to 0.001 meters, which is 1 millimeter. Okay. Use the significant figure, use the sig fig, significant figure for these measurements according to the resolution of your instrument. Okay. So what you're going to do when you display the correct number of significant figures here, you will have to show up to the third significant figure, right? I'm going to do that for you. Here you go. Right click, format cell. We are going to change from scientific to number, and you're going to put 3 decimal places, which correspond to the resolution of your ruler. Okay? And you gotta do the same for Y. Gotta do the same for Y. Right click, format cell number 1, 2, 3. Okay, and we gotta do for the other ones. Don't forget, okay? Don't forget to put the units here. When I was correcting lab number 1, I saw lots of students who forgot to fill up the units in those cells for the lab number 1. Make sure you don't forget that, okay? For the R, you don't for the, what is R? R is the radius. Is the radius of that point, the distance, right, from the center of the
Professor, I have a question. Sorry. I didn't
Yeah.
see which points did you pick out for that graph you just made?
You mean this graph here?
Yeah.
Oh, okay. I'm gonna go through that.
Oh, okay, okay.
I'm gonna go through that. Don't worry. Okay. I'm even going to erase it so you don't get confused. That's why I thought that we had done those graphs, because the graphs were already here, right? Okay, so here you go. R is the square root of x squared plus y squared, right? Now, for the voltage, right? For the voltage, you have to look at that table that I provided to you, right? In the canvas. Let me get that table. It's everybody has that table for significant figures. Let's see if I can find it here. If I cannot find, I have to go to the canvas. Let's see here. Raw data. No. Nope, it's not here. Okay, so I gotta go to Canvas and download from there.
I was gonna say I have different numbers for my graph to the graph you had right now. I don't know if I'm
Yeah.
like, it's supposed to be different. Okay.
Yeah. Everybody's gonna be everybody,
Oh, okay, okay. I was
Not
confused.
everybody, right? I have a total of 8 different sets of numbers in there, but the genetic appearance should be the same, okay? The genetic appearance, just like you saw here, everybody should look somewhat like that. The points are going to be slightly off, but everybody should see something like that, like concentric circles, okay? And again, the numbers are not exactly the same, okay? So let's go here. And okay, here you go. That's the one I want. I'm going to download it. Natalia Cordova. Yeah, resolution. Okay. Okay, so did I download my document? And now I can start sharing the screen again with you. Here you go. That's the document that you must have. Okay, and it should, see. Strange. Let me, for some reason, it is not opening in PDF. Okay, and I'm going to copy and well, let's plot the graph first, right? And let's worry about the significant figures later on. That's what we are supposed to do, right? So let's plot the graph first. So procedure, check, actual measurements. Okay, now plot the graphs. Plot the equipotentials. Equipotentials. Okay, plot the equipotentials. How we are going to plot the equipotentials? Let's see if I can document, highlight what you're going to do. Highlight the X and Y coordinates for V equal to 0.5 volts. Okay? That's what you have to do. Here we go. It's going to be, the procedure is very similar to what we did before, okay? X and Y, see that's 6 data points, 6 measurements. Remember that? We did something like that in lab number 1. Okay? And then highlight, next, click, insert. Okay? Click, insert. Insert. At the top of Excel, is that the insert should be 1, 2, 3. The third one from the left to the right. Okay, insert. The third option from the top, at the top left. The third option, the third option from the left to the right, from the left to the right, at the top left. Okay, click insert at the top of Excel, at the top left, of the Excel spreadsheet. The third option from the left to the right. Right, and then let's go back. Insert, right? And now you have all those options right in here. We have all those options here, and you're going to go to chart option, right? And you highlight this one right in here. Select scatter plot. Okay, select the scatter plot. Do you see my first equipotential? Select. Okay, click insert. Select scatter plot. With no lines, right? With no lines connecting the data points. Notice that we have other options, right? We have lines connecting the data points. You don't want to select those ones. Let's see. Let's take a look again. Insert chart, right? Look for a scatter plot. Insert scatter XY. And then you have all those options here. You want this very first one with no lines in between the points. Okay? That is my first equipotential at 0.5 volt. Okay, this is my first equipotential. This is your equipotential for half volt. Now, click one of the data points in the graph, right? I'll click on one of the data points in the graph. Let's do that. Here you go. I click one and all the data points are highlighted. Okay, right click this point and select data, the option select data. Okay, let's write it down. Right click this point and a drop down window should appear. Okay, highlight, select data, highlight, select data. Are you following? Okay, and this window should show up, right? This window should show up. Then, you know, series 1 corresponds to half volts. Okay, that's one of the one set of data for half volts. So what we're going to do, click edit and write 0.5 volts. Okay, so I'm going to write that down here. Highlight select data, click edit, right? That's what we did. Click edit with series 1 highlighted. Okay. That's exactly what I want to make sure that's what we did. Here, I'm going to close it, right? Yeah. Click edit. See, series 1 is highlighted. Click edit and you write it down 0.5 volts. Click OK. And now we have the correct name, right, for your first equipotential. So click OK. Click OK. Okay. Next, we're going to plot our second potential. Okay. Then you're going to click add. See here? Add. Okay. Now, and what's the name of this window? Select data source window. That's the name of this window. Do you see the series 1 changing to half volt here? Right? So going back, click OK. This select data source window should return. Okay. Click in the button, add. Button. Okay, it's went in, add. And now when you select that add button, now you're going to have the opportunity to plot your second equipotential. But before, you know, just a name 1.0 volt. Okay. And then what else do you do? Let's see if I can. Yeah, this window here is getting in the way, unfortunately. I gotta let me do something. I gotta move it. I cannot move it. Yeah, see, you gotta make sure that this window is not in your way. Let me move. Yeah, here you go. Now it's not in your way. It can be placed right here in front of X and Y for half volts. When the window is right here, we won't be able to select the data for 1 volt. Okay, that's why I'm repositioning it here. So here you go. Let's go back to where we were. Click, right click, select data. Okay, we're back. Add 1 volt, 1.0 volts, right? And then series X value. Series X value is going to be the X coordinate of the data point for 1 volt. And the series Y value is going to be the Y coordinates for the 1 volt. Okay? Let's document that, right? So here you go. Click the button add. At the top of the window, type 1.0 volt. At the not the total at the next box, click your mouse in the second box and select the X coordinates of the 1 volt equipotential. Okay? And then you do the same for the third box. Click your mouse in the third box. Make sure you clear the and next, clear the third box. You have to clear the third box first because it always show a number 1 in there. That's I do not know why they have that. Next, clear the third box, and here you go. Select the Y coordinates of the 1 volt equipotential. And then what do you do next? Click OK. Click OK. And that's what I'm going to do. Here you go. Click OK. Then what do you do next? Repeat for 2 volts, 3 volts, 4 volts, and 5.5 volts. Okay? My first equipotential, my second equipotential, right? So let's go there. Repeat steps for J through for N for 2 volts, 3 volts, 4 volt, and 5.5 volt. Okay? What time is that? 12:10, right? When was our last break? Let's keep on watching for this break. 11:27. Okay, let's finish those. Here you go. Add 2 volts. Click the X coordinate. Select all the 6 coordinates of the X, right? And then do the same for the Y. Don't forget to erase this number 1 there. That's always there. And here you go. We have our third equipotential, right? Click OK. Add 3 volts. X value for 3 volts. So here you go. We should be able to move here X. And don't forget to erase this number 1, Y volt, right? Click OK. And 2 more, right? 2 more sets. 4 volts. 4 volts. X series. Y series. Click OK. And the last one, 5.5. X series. Y series. Right? Click OK. And now click OK. Okay? That's how it looks like. That's how it should look like yours. And I'm gonna, click OK again, right? Click OK. You finished plotting your equipotentials. Like that.
Professor, I'm still struggling. Like I got stuck after you said to add the things, because on my end it looks different, like where to add the information. Like it's not like when I right click, it shows me like a column but it doesn't say add or anything. That's why I'm kind of confused. Like I don't know how to add the other ones.
Which
If
computer
you
are
have
you
a
using?
Mac, it's on the top right corner. It says select rows or select
Oh,
data.
Select data.
It's on the top right corner.
cool. It's the Mac, right? The Mac has some. Is that the
Yeah,
Mac?
mine is different too because I have a Mac. Yeah.
Yeah. Okay. Yeah. The Mac has a slightly different.
Okay.
So you should be able to. Do you get now?
A little, but I don't know where to add the things. Like I'm kind of confused. Like I did everything right, but then as soon as you started adding the other ones, like the 1.0 and the 2.0, I don't know how to add that. Like it looks different on my end. I see where it says data and format, like to add it, but I don't see where I could add like the X and Y values.
So double click the graph. Double click
Hmm?
the quadrant.
Yeah.
Double click it, and then on the top it says select data. Top right.
Select data. Okay, I see that, but I don't know how to add like how do you highlight it and then add it to the graph? Because I know it says where it says setup. I know you
Once
could add
once
it.
the Yes, so once that box comes out, you're gonna have to click the plus button to add one of the columns, and then you add the X and Y values there.
Okay,
Okay.
thanks.
Sorry to take over, Professor.
Okay. Okay. So if you still have any problems, stay for the office hours. Okay. So you can figure out together how to do that in your computer. Hey, Stephanie, right? That's having a problem.
Yeah.
Okay. Yeah. If you still have any problems, just, stay for the office hours, and then I'll help you out. So here you go. So we finished plotting the equipotentials. And what is next? Well, next should be, here you go. Don't forget to, put the labels in the X and Y axis, right? Axis. Labels in the X and Y axis, just like I'm going to do. And he goes select, add chart element, axis, primary horizontal. Oops, no, something happened here. Let's see, what did I do? Axe title. Okay, go back. It's axe title that I want. Chart design, add chart element. Axe title, not axis. I highlighted axis before, right? You have to highlight axis title. Primary horizontal. Primary horizontal showed up here. And do that for the primary vertical. You know. And then you go ahead and type. Make sure you make boldface. Make a large font. Okay. I prefer that you use 18. Here the x-axis. X-axis. What's going on here? Okay. X-axis. And you can also make larger too. I like bold face. Bold face. Make it 12. This one too. Bold face, 12. Right? And bold face who's coming. There is a message here. Let's see. And you can also just click on one of the of the points in the This message is for Stephanie, right, Elizabeth? Okay. So here you go. Y-axis, right? 18 y-axis. Oh, didn't type it. Y-axis. Meter between parentheses. And here are the equipotentials. Ba, 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 and another one. Okay. Two graphs, just like before. Here's my first graph. Now let's go for our second graph. Second graph is the average and R bar. The bar in the R means average. Okay. Type it. Let's see. 11, 12, 19. Let's go another 5 minutes. Okay. So here you go. Plot. Here you go. That's what you're supposed to get. It's not going to be a straight line because it's a different electrode configuration. Okay. Should be something like that. And let's not forget also to add the chart element axis. Yeah. Let's see. Someone is singing here in my. Did you help, Airly? Okay, I'm gonna mute Airly. Okay. Here you go. So here you go. Add chart element. Add chart element. Axis title. Primary horizontal. Huh? Primary horizontal didn't. Okay, here you go. And primary vertical. Okay. The vertical is going to be the average V. The horizontal is going to be the average R, the R bar. Okay. So let's write that down there. Put the labels in the X and Y axis, and here you go. Plot VAVG versus R bar. I'm going to put R bar. Okay. $12.21. R bar. And now that you got everything here, I'm not going to label the axis. I want you to do that yourself, okay? And once you are done with that, plot the equipotentials. Now let's go back here. Then you can start work on the units of the tables. Okay. Very important that you document the units, okay? Very important. Otherwise, you will not know which unit you're using. You do not know if it's going to be meter, do not know if it's going to be inches or feet, right? There was this case of an engineer. For the second graph, I selected, here you go. See those two here? R bar and the average. Elizabeth? So you select those data here, okay? 6 data points. Okay. And then what do we do here? Here, we are going to do the following. We are going to have a trend line, and the trend line should be I see the logarithmic trend line. Yeah, it's a logarithmic trend line. Okay. Display equation chart. This one's going to be different because it's not linear. Okay. But actually, I want you to display two different equations here, the logarithmic and also, here you go, trend line. I also want the power, okay, and display R square. And then, see, now we have 2 different fit here for the same data. Then you tell me which one has a higher R square, right? Is this one has a higher R square or this one, right? Let's write that down. Now plot this one. Okay, put it back here. Work on the plot the average versus the R bar. Okay, that's that should be another item here. Okay, A. Display. Select. Right click and select trend line. Okay. Select logarithm fit and R square. That's the first curve fit that you have. Then right click again and select trend line again. But this time you're not going to select the logarithmic, right? You're going to select power, right? Select power fit and R square. Okay. Which regression equation has the highest R square? Okay. Again. Okay. The one with the higher R square is the best fit. Okay, here you go. Is the best fit. Let's take a break, right? And then I think we can finish it before 12:50. We have almost, you know, let's go straight without a break. Otherwise, we won't be able to finish. Yeah, let's go straight out without a break. We should finish at 12:50, right? Here you go. This one, oops. This regression equation is for this curve. This other regression equation is for this. Let's see, this curve here. This one is the logarithmic. The other one is the power fit. So Excel allows you to fit not just straight lines, but allows you to fit other equations. Let's see. Did you click OK there? Let's do that together again. Here you go. I'm gonna erase it, right? I'm gonna erase it. Click, right click, add trend line. And we are going to do a logarithmic display equation and display R squared. Is that what you do? You got the first one, right? Elizabeth? Okay, good. Now let's do the second one. Click again one of the data points. Here you go. Yeah, see, selected everything. Sometimes you have to, you have to click exactly there in the data. In the data, right click, see, I can select data, I can add trend line. Okay, I can, let's see, logarithmic power display equation chart R squared. Okay, see if you can do that. Sometimes you miss sometimes it doesn't highlight because you miss the dot. Are you using a Mac or a Windows?
No, yeah, I have a MacBook. It's only giving me the option to reformat the original trend line. It's not letting me add another one.
Okay, so let's do the following. Type plot a second graph. Okay, there's a way to go around that. Plot a second graph, and then the second graph where you're going to have two of those graphs, right? One with the logarithmic fit, and the other one with the power fit. Okay, if you have a problem adding a second, right, a second trend line, you can do this way. So here you go. I'm going to, that's the one I want to erase, right? Here you go. Oh man, let's do it again. So I'm going to do that from scratch. Here you go. Insert, chart, click one, right click, add trend line, logarithmic, display equation R squared. Okay, that's one graph. And then you just repeat what you did, right? Highlight it again, plot a second graph. The graph is going to be exactly the same. The only thing that's going to be different is going to be the regression equation. Select one of the data points, right click, add trend line, right? We did, now you're going to do power, display. That works for you, right? And don't forget to put the labels, the axis labels. Okay. To minimize the graphs, it's nice to have the two equations there, right? But if you cannot put the two equations there, just plot two graphs. Okay, so here you go. And now let me check with, we have 20 more minutes to go. I want to check with everybody if insert, let's see, insert copies. Okay, lab 2 today is the 26, right? And I want to know if you plot all the graphs that we are talking about, okay? For some people, you are going to plot just two graphs. For other students, you're going to plot, other students are going to plot three, right? If you have the same problem that Elizabeth had. Clear contents. Yeah, here you go. Abir Ahmad, did you plot the graphs? Oh, hi. Here you go. It's this one that I want. Clear contents. Okay. Let's see. I don't see Abir Ahmad here. Looks like Abir left. Okay, left. Next, Nestor Alvarado.
Yeah, I'm following along. I
Okay,
have the graph.
all the two graphs, right?
Yeah.
Good. Monte, did you plot all the two graphs? Monte here. I see Monte here. But Monte is not answering.
Sorry, Professor, I was having trouble hearing.
Okay. Did you plot the graphs?
Yes.
Okay, good. No problems, right?
No, none at all.
Okay, good. Hasty here. No, Hasty is not here. Isabella is here. No, Isabella is not here either. Justus Bowden. What happened to Justus? Okay, looks like Justus left. I'm gonna put it left. Here you go. Alexandra?
Yeah, I'm here. I'm following along.
Okay, did you plot all the two graphs?
Yes.
Okay, good. So it's the equipotential plus the V versus X, V versus R, not X, but R, right? The radius. Next, Benjamin Herbajal. Okay, good. Any questions, Benjamin? No? Okay, good. Elizabeth Castellano.
Yeah, I did the two graphs.
Okay, good. Natalia Cordoba. Oh, you're doing it now? Okay, so I'm going to put that you're working on that. Jacqueline Delgadillo. I don't see Jacqueline here, huh? Looks like she left. Okay. Left. Jenny Diaz.
I'm not able to access anything like through Canvas at all.
Okay, you have to Jenny Diaz, right?
Yeah.
Did you download that to your hard drive?
No, like you know how there the first lab there was like submission and then I had to download it. Like I don't have nothing that
Okay.
appears.
Let me check. Let me check because I think I've uploaded that for you. Let me stop sharing the screen. Okay, let's see. Course. Assignment grades. Jenny Diaz. Jenny Diaz, I see it here. See, it shows that I upload that. Let me upload it again. Okay, that's the only thing I can do because submit for a student, right? I don't remember what was the, but lab slides, lab number 2. Nope, not this one. Raw data. Lab 2. Okay, Jenny, here you go. I'm going to submit it. I see the file here. See if you have the file now in Canvas. Hey, wait a minute. Is it possible? It looks like I put it. Oh, I know why. I see. I put in the wrong place apparently. Okay, let me try it again. Sorry, Jenny. So here you go. Submit for student. Here you go. Should be on lab 2 now.
Yeah, I got it. Thank you.
Yeah, it looks like I put in your lab 1 instead of lab 2.
No, that's okay. Thank you.
Okay. Okay, so go ahead and work on the spreadsheet of yours, and I am going to working. I'm going to put working. Valerie Diaz, did you plot the graph, Valerie?
Yes, I plotted them. I just haven't formatted them yet.
You didn't format. Okay, good. So yes, I'm gonna put yes here. Juan Escalera, did you plot your graphs?
There's only two graphs, right?
Yes, that's right.
Yeah, yeah, I did both of them.
Okay, so you have to do the equipotential and the second graph. Don't forget the second graph has two regression equations, right? Two
Yeah,
regression.
the two trend lines, right?
Yeah, two regression
Yeah, I
equations
did that.
and two R squares. Okay.
Okay.
Okay, so he go. Bianca, did you? Okay, okay, good, you did. Okay, don't forget start working on the units, right? Since you finished the graph, you work in the unit and work in the significant digits. Let's see, is Dana there? No, Dana is not here. Next, Edwin Gonzalez. Hello, Edwin. I'm not hearing from Edwin. I'm gonna put a star here in his name. Okay, working on it? Okay, good, thank you. Next is Ellie Gonzalez.
All done, charts completed.
Okay, did you do the significant digits and the, how do you call it? The units.
Yes. Units, sig figs are all done.
Oh, okay, good. So it looks like you finished everything, right? Is that right?
There is the table at the bottom that I just need to make sure I'm correct on what to fill in for those red spots, but
Okay.
yeah, looks
Okay.
like just values, so yeah.
Okay, good to know. We'll get there. We'll get to the table at the bottom. Manuel, are you there? Let's see, Manuel Hernandez, right? Yeah, I don't see Manuel here anymore. We're gonna put it left. Samantha? Samantha is not here either. Okay, yeah. Put the O here and CJ. Let's see, CJ is here. CJ seems to be here. Hello, CJ. Did you plot the graphs? Seems that CJ is not in front of the, oh, here you go. Can you hear me? No, I cannot hear, but I can read your text. Okay. I don't see lab 2 in my, okay, in the location. Let me check. I'm not sharing the screen with you, right? CJ Houghton, right? CJ Houghton. Yeah, okay. I'm going to upload the graph. Don't forget. I'm gonna upload the graph for you. Now you have the graph there, CJ. Confirm that you can download it, please. Okay, good. Thank you. Next, so working. I want to put that you're working. Luis Leal, is Luis Leal here? Nope, I don't see Luis Leal here. Amber Lopez. I don't see Amber. Looks like Amber left. Arely Lopez. Arely Lopez left as well. Huh? One more. Genesis.
Hello, I'm working on it.
Okay, working on it. That's good. Do you need any help?
No, I'm good. I got it.
Good. So Mary Michaelian, are you there, Mary? Hello. Okay, here. Okay, did you plot the graphs? Did you graph, Mary? Okay, good. So start working on the remaining of the lab. Okay, do you have any questions? Nope. Okay. So let's see. I'm not sharing any screen yet. So Galia. Hello, Galia. Okay. Oh, you plot. That's good. And so you can start work on the units and the significant digits. Now let's go for Ramon. Ramon Olivares.
Yeah, I'm all done with everything, Professor. I'm just confused. Do you want us to do the sig figs on the chart one, the first chart?
Let me see the sig figs.
And I have 4 sig figs on mine, on all of them across the board.
So let me see. Let me share the screen with you. Okay. So yeah, you have to do the sig figs for everything here. You're talking about the first table, right? Not the first chart, but the first table, right?
Yeah.
Okay, yeah. You have to do sig figs. Yeah. Oh, wait a minute. Everything that's in red, okay, they are, you do not have to, okay? But you have to do for votes, X and Y. Votes, X and Y, you have to do the significant figure. But the parameters that are in red, you don't have to worry about them. Okay? To do the sig figs for the R is going to be very difficult, very complicated.
Yeah, that's the one that's confusing me. I'm
Yeah,
not too
okay.
sure.
Yeah. See, it's in red. And
Yeah.
I put a message there too. Let's see. Am I sharing the screen? Yes, right?
Now you are, yeah.
Okay, now I am. Okay. So someone is trying to log in. Okay, here we go. Good. So, and here you go. You know, sig figs here. Everything in red, you don't have to worry. Okay. The last one. Yeah, the last table is all you have to do is to copy what you have here for the regression equation and the R square, okay? And then you find the CL. No, let's see. Go. What time is that? Oh, 5 more minutes to go, huh? So Taylor Forn is here. Taylor, I don't see Taylor. Okay. Jeremy Pittman, are you there, Jeremy?
Yes, I'm here.
Okay.
Yeah, I did. I have both graphs completed.
Okay, good. So start working on the units, right?
Yep.
And the sig fig. So here you go. Stephanie Ramos.
I did the first graph, but I never finished adding the other data information because I'm just stuck. Like I don't know how to add it on my Mac.
Okay, you have your Mac. Okay, Stephanie, right? Yeah, okay. Stay around after the office hours, okay? And let's figure out together how to do that in the Mac. Okay, so I'm gonna put here working. And Leslie, I'm gonna
Yeah, I
put
finished plotting it.
Mac. So in this meantime, Stephanie, you can do the units and you can do the sig figs, okay? And let's see, Leslie, did you plot the graphs?
Yeah, I plotted them. I'm just working on the units.
Okay, good. Jason?
Yeah, I did it.
Okay, good. And last but not least, Hema Torres Navarro.
Yeah, I did it.
You did that, right? So I want you now to do, we're already running out of time, okay? So you gotta do the unit. I want you to do the units and the, how do you call it? The sig fig, right? Plus what else we have? We have unit sig fig and this last table here. We have this last table here. The last table, we notice that, you know, how many data points do you have, right? For the V is, you know, you have 1, 2, 3, 4, 5 for the second graph. How many points do you have for the second graph? You have 1, 2, 3, 4, 5, 6, right? Then you type the equation for the power fit. And you write down, you type the number for the R square here. For the power fit. The power fit, my power fit is 0.9332. Then you repeat that for the logarithmic fit. Okay? And don't forget to do the CL too, right? Using that table that I mentioned, that I showed to you. CL mean and mass. And that is the last table. So I want you to, I think you can do everything else on your own, right? So let's see, the lab number 2 is due next week. Okay, and it's 12:48 right now. One more student coming. Come on. And here you go. Do it at home. Home. And if you do not have any questions, we can stop here and I will be here for my office hours. Okay. So
Professor,
yeah,
I have a quick question for you.
Uh-huh.
I was trying to like get like my microphone situation figured out. So I had to like leave like the Discord. I'm sorry, the Zoom real quick, and I think whenever I left was basically when you were calling out, like going through like each people to basically see what we have done. I was listening to like the entire time, and I just want to confirm that I have basically everything done and set up for like the for like lab 2.
Okay, so let me see. Justus Bolden, right?
Yeah.
Okay. Okay, so you're back, right?
Yeah, I was just trying to like figure out something with like my mic because like every single time I join the Zoom, like my mic always like doesn't work. So
Yeah. If your mic stop working, make sure you type there in the chat window, okay? The chat
okay,
window
sure, thank you.
always work. So if
Okay,
I even prefer that the students type the message in the chat window.
Okay, sure, sounds good, Professor. Thank you.
Welcome. Okay, so let's see. It is Stephanie that's having a problem with the Mac, right?
Yes.
Okay, so you're there, right, Stephanie?
Yeah.
I want you to share your screen with me.
Okay.
And let's see if we can fix that and figure out how. Sometimes the Mac is a little bit complicated, and also they have the Mac. Some Macs have a different setup.
Yeah.
And
I'm sharing it, but it said it's sending you a request.
yeah. Now you can share.
Okay. Let me see. Is it sharing now? Sorry, I just want to make sure. Oh, there you go.
Yeah, let me see if it's sharing your screen. Because I am sharing the screen. Okay, now you can share.
I don't know if it's showing now. Sorry.
Yeah, I see it. Yeah, let me leave need to about the.
How do I make this bigger?
Okay,
This is
so
the part of the graph where I'm trying to add, but it says it here on the side, but I can't put the number here.
Okay, so
because it says X values.
Let's try to do in the way that I was doing first, right? And let's see what. Click one of the data points. One of the data points in this one. Oh yeah, see, I highlighted everything, right?
Yeah.
Now right click. Yeah, it doesn't do. So let's see. You said that there is a.
It says this on the side. But I can't type in the X value right here.
It's so small for me. Can you zoom in?
Yeah.
Select the chart, data, format, more rope. Let's see. I see setup, columns, more options, show, empty cell. Click on setup again.
Oh, where's
Setup,
it's right
yeah.
here. It's this,
Yeah,
but I
okay.
can't like tap anything here.
I see. Columns, rows, and click on the data points again in the figure, in the plot. I know that we're doing that more than once. Let's see. A vote. Sometimes the on the top right shows up something.
It would be this right here, but I don't
Yeah.
know what
Source.
to add.
More options. Column rows show empty spots. If someone is coming.
So I'm just like confused because I don't know. I got
Yeah,
stuck on this.
I'm afraid that you have to yeah. The editing catch up. Let's
I don't know how the other guy in the class did it because he told me it was on the side, but I don't know if his looked the same like mine. Because he said he was able to do it from here, but
okay, let's see. Chart title, legend, horizontal axis, close the horizontal axis. Let's see. Let's see if you have vertical axis, close the vertical axis as well. Click there on the vertical axis. I want, yeah. Oops. See, there's another one. Series name. See that? Let's see. Let's see. Can we add another series? Maybe we can add another series there. Is it possible?
I don't know how to do that.
Little labels.
I can't touch none of the.
Yeah. Check. Did you get the name of that guy that has a Mac too?
No, I forgot his name. I think he was like right. I think his name was like before my name. I think, I'm not sure.
Okay. Okay. The other option, you might, if you cannot, at this point, I do not know how to fix that. Okay. Let's see. Maybe you should just do several graphs with different. Yeah, let's do that.
All the different ones here?
Yeah. Instead of doing just a single one with several equipotentials, do half, 1, 2, 3, and 5, and 4, 6, right? Do 6 graphs with each equipotential. If you don't figure out how to do that in a single graph, just do 6 different graphs of each separate equipotential. Okay.
Okay.
And then all you have to do is to plot that other graph, that's V and R.
Okay.
Okay. That I can. Now let's see. What about?
I don't know how to stop sharing.
Eli Gonzalez. Okay.
Got literally a few more moments right now if you're able to touch base with me now, unless it needs to be in private.
Okay, who is that?
This is Ellie Gonzalez.
Okay, good. So Ellie, I didn't see, let me see. I tried to download your lab 1 and I didn't see it there. Do you know what happens? What happened?
Well, I have no idea. I see it submitted. It says lab 1, download lab 1, Ellie Gonzalez, XLSX.
Let's see. Let's see what happened here. That's why you didn't, Ellie Gonzalez.
It says
right?
submitted 9:48.
Yeah, let's see. Submit for student. How do I get? There is a way. Late paragraph. No, that's not what I want. Can you submit it again?
I mean, it's right there.
I'm gonna. I cannot share my screen because there's the grades of the other students here. So let's see.
Yeah, that's me. That I'm sharing my screen.
Are you going to share your screen? Okay, good.
You see that? That's lab 1.
Yeah,
And my
lab
download right here. It's all submitted March 12th.
one moment. Let me get here. Go ahead, share your screen. Are you sharing the screen?
I am sharing.
I don't see anything.
Oh, let me stop sharing and try again.
Yeah. Stop sharing. Start again.
You see
Okay,
it now?
I see it. Now I see it. Yeah.
So you can
Submitted.
see submitted March 12th.
Yeah.
Here
Okay,
it is
so
right here.
yeah. Let me see if I can download it because earlier I couldn't get it. Let's see what's going on here. Late, no, let's see. Grade, speed grader. You have to work now, right? Is that right?
I have to work soon, but I do have a few minutes. So if
Okay,
we can
good.
tackle this now, I'd rather tackle it now.
Yeah. So oh, wait a minute. Is that the one? Must be this one here. Huh. Interesting. Let's see if I can download this one. Ellie Gonzalez. Let's see.
Is it because
Yeah,
I
I
renamed
got
it? Should I
it.
not rename it?
Yeah, I got it. I got it. Okay, for some reason I couldn't get it before. It was in a different
That's
place.
okay.
Okay, now I
Would
will
you
correct
prefer
that.
would you prefer if I don't rename it? Was that part of the problem?
I don't know. I don't know if that was the problem. You don't need to rename because the Canvas already does the renaming for you automatically. Okay.
Okay.
Okay. So I got it, and I will correct that. And once I get corrected, I will upload the correction. Okay.
I appreciate that. Thank you so much, Professor.
Thank you for your help. Bye bye.
Of course.
Okay. Is there any other student here?
Yeah, I think the rest of us also had the
Yeah.
same issue as Ellie.
Okay, so let's go one by one, right? Let's see. Let's see if I can download. I found Ellie's lab report, and who is that I'm talking to?
Jason.
Jason, right? So
Yes.
let's see. I gotta go here. I'm not sharing the screen, right?
No.
Okay, good. Lab 1. Jason Strike? Straight.
Yes, Jason Straight.
Straight. Okay. So let's see. How did I get? Maybe it's here. No, that's not this one. Straight. Straight, please. Sometimes those things go some strange places, and I can't seem to find them. Let's see.
I see. I did not rename mine like Ellie. I kept it as the downloaded name when you first originally posted it. But I did check on my own site and it is there, so hopefully you can see it.
Okay. So let me see the date assignment lab 1. Is this one here? Okay, looks like I found it. But let's see. But it doesn't look like your name is in there. Let's see. Okay. Did you put your name there inside the document?
Yes, I put all of the information inside the document, including my
Inside the
name.
document. Okay, so let me
Yes.
see if that's the one. Yeah, that's the one. I found it. Thank you.
Okay, so it's there?
Yeah, let me put Jason straight. Yeah, Jason. And then I will correct it. And okay, who else?
Thank you very much.
Me, Professor.
What's her name?
Miss Jenny.
Jenny, right? Jenny Diaz.
Yeah.
Let me go back. Change. Let's see. Lab 1. Lab 1, workbook was saved. Let me see if I see it in your case. I have it somewhere else. Okay, I have yours, Jenny. Good. Who else?
Okay, thank you.
I had the
Me,
same problem,
Professor Emma.
Professor.
Yeah, one at a time. Let's see.
Yeah, I had the same problem.
So
This is
we have
Elizabeth.
okay, Elizabeth Castellano, right? Let's start with Elizabeth Castellano. And let's see. Okay, let me go here to the so assignment. Elizabeth Castellano. Okay. Now lab 1. No, it's not here. Is it here? Download submissions. Okay. Okay. It looks like I found yours. Let's see. Elizabeth Castellano, right? Let's see. I have here, Elizabeth. Idea, unexpected error occurred. Cancel. Huh. Let's try it again. Okay. Huh. Now it's opening correctly. It's strange. Okay, so I found it, Elizabeth. You do not have, so you're telling me that you do not have my, so that must stay up. Strange. You didn't get the PDF file, you said?
Yeah, I couldn't find it.
Okay, so I have it here. Let me upload it again.
Okay, thank you.
So let me, I do not know what happened, but wait. Now, let's see, Elizabeth Castellano. Okay, submit for student. I am going to make sure everything is correct here. Okay, yeah. Seems that everything is okay. Castellano. Now, I check if you can find it now, the correction. Okay. And now, while Elizabeth does that, let me help Mary, right, Mary? Are you there, Mary?
Hey, Professor, this is Hema.
Okay, Hema.
Yeah, I also didn't get a PDF for
Okay.
Lab 1.
Okay, so let me see. Let me, Hema, right? Let me see. Yeah, I have your PDF here. Okay. Let me see. Yeah, I do have your PDF. Let me upload it again. Torres. Okay, see if you can find your PDF now. I'm going to submit. Okay. Did you manage to find your PDF, Elizabeth?
Yes.
Yes? Okay, good. Now let me see. Mary, are you there, Mary? Doesn't look like Mary's in there. Let me, Mary, okay. So, Hema, did you manage to download your PDF?
Yes, I did see it. And then one more thing, I'm missing a grade for February 26th for the lab.
26. Okay, so let's see, February 26. February 26. That Hema, right? Hema Torres Navarro. Let's see, February 26. Yeah. Okay. So February 26. Yeah, you were present. So let me see. What grade do you see there for February 26?
It just says missing, like it doesn't have a grade yet.
Okay, for some reason. Okay, so let me put it now. For some, why is strange? Huh. Yeah, I type it. Sometimes we type it here, it doesn't show. Okay, now you have your grade. Okay.
Perfect. Thank you so much.
Okay, February 26th. Anybody else?
Have a nice day. Take care.
You too. Bye-bye.
Hi, Prof. Could you hear me?
Hi, is that Mary?
Yeah, sorry, my mic wasn't working.
Okay, good. So did you get your PDF there, Mary?
No.
Did you check it now?
Yeah, let me check it one more time.
Yeah, because I just uploaded it. I have it here. For some reason, it didn't went through the first time.
Okay,
You got it?
yes. Yeah.
Okay. So,
All right.
make sure you put all the units there, right? I'm looking here at your correction. You missed several of the units here. And your CL was incorrect, apparently. And also you missed the unit in the last table. Okay?
Okay.
So everything else should be okay. Remember,
Okay.
everything else that has a color code, that's because, there's a mistake in there, okay?
Okay.
Anything else?
No, that's it. Thank you.
Welcome. Tá quente? Tá quente? Ah, minha. Office hours, relatively 135. What? No, they haven't spoken.